Welcome back to the R Primer tutorial. I'm Ty Taylor from the Operator's Manual for the Planet, and this is a tutorial to get you up and running in programming for data analysis in R. This is a video in a series of videos for this tutorial. You can find the whole playlist of videos in the notes below this video on YouTube. In those notes, there's also a link to a Google Drive folder, which contains the tutorial files that we're using here. So if you want, you can download and open up the R tutorial with blank in the title, and then all you have to do is type what I type as I type it. The easiest way is going to be for you to put this YouTube video on an external monitor or on your TV or on your phone even, because what you're going to do is just watch me on the video and then you type in whatever you see me typing into your own computer. So you'll need two screens to do this, okay? Cool, we're cruising along. We have done the basics of ANOVA's regressions and plots and R and objects and vectors. And now we're going to get into functions before we do matrices and what you've all been waiting for, data frames. Let's go. So, part 5, built-in functions and how to get help on them. R is functions. There are many that are built in and you can make your own. Functions are things that do things to numbers, text, whole data sets, and really everything. Functions can do anything. Functions are basically the vocabulary of R. So let's see how these functions work. You've already seen a few of them, like data, head, C for making vectors. Let's look at a couple more. Functions for basic stats. We've got, let's look at the mean of our vector 2, v2. We can look at the standard deviation of v2. That's just SD. We can look at the maximum value of v2, just with max. And we can look at the minimum value of v2, just with min. Now, by the way, if I'm ever typing and moving forward too fast, just hit pause on the video and give yourself a moment to catch up. You can go into YouTube and click the gear icon, go to playback speed, and you can change the speed of this video to 0.75, 0.5 even, or 1.5, 2x. All functions look like this. There's a function name, and then parentheses are opened, and then you give the arguments to the function, which are separated by commas. Arguments are parameters, or you can think of them as questions that need answers. Let's look at an example here. We'll try the function rnorm, which generates a random series of numbers from a normal distribution. You know, that normal statistical distribution. And it has a few arguments, so just copy me for a moment. So the first one, we'll do n equals 10, comma, space, mean equals 5, comma, space, SD equals 2. Now your numbers that appear here in the console will be different than mine because R is doing a random number generation here. But what it's doing is it's giving 10 numbers. We told it to return 10 different numbers drawn from a normal distribution whose mean value is 5 and whose standard deviation or width of the distribution is 2. So the function rnorm contains 3 arguments that you need to know, and they are n, mean, and SD. Those names are fixed. They're not like the objects that we created before that you can name them anything. These are the names of the arguments in rnorm. You can call arguments to a function without naming them. So let's do that again here in 5-1.3. It's supposed to be. I got my dashes and dots mixed up. So let's call this again. We'll go R norm, and we'll just type 10, comma, space 5, comma, space 2. Execute that, and that works perfectly fine. R didn't seem to have any problem with it. We were able to call these arguments without names because we put them in the right order. Notice how if I mix up here the 5 and the 10 of R norm, and I call that, now it makes me only 5 numbers because I put a 5 in the first position and it knows that the first argument is supposed to be n. You can call arguments out of order if you do name them. So let's call R norm, and we'll just mix things up a little bit. We'll say mean equals 5, n equals 10, and SD equals 2. So now again, we got a return of 10 random numbers. It knew to give us 10 because even though we put it in the wrong position, we named it. We said the argument n is equal to 10, and that was fine. Arguments have default values in functions. Some do, at least, not all of them do. So for example, with R norm, we can just give it the argument n equals 10, execute that, and it returns 10 values. And that's because it used the default values, which in this case are, let me just check. I'll show you in a second how to do this. I'm going to get the help on R norm just by typing $R norm. And when I scroll down here, it shows me that there are 3 arguments, n, mean, and SD. And the mean and SD have a default because it says here mean equals 0, SD equals 1. The n doesn't have an equals there, so it doesn't have a default value. So when I told it to give me over here 10 random numbers, but I didn't specify the other 2 arguments, it used the defaults mean equals 0 and standard deviation equals 1. What happens when you fail to call arguments that don't have defaults? So just delete that hashtag that was in front of this if you have that. Execute just R norm without a default value. And it gives you an error at the bottom. Error in R norm. Argument n is missing with no default. So again, let's look back here at the help. You see that there are 3 arguments, n, mean, and SD. N has no default, so you cannot call the R norm function without specifying that argument. If you do, it will just give you an error. Here's an example use of a simple function. We'll call our iris data again, and let's just take the mean value of iris sepal length. So that's just taking the mean of all of the values in this vector. The mean value was that. To access help on a given function, you just type the question mark and then the function. So for example here, I'm just going to type this so you can type after me, 5-1.6. We'll go question mark paste. Execute that, and it opens up the help window here, and it shows you here the name of the function in base R. That's because it's in the base R package. We'll learn about packages later. And then it gives you information on paste. Now, the most critical information from the R help files on functions are what are the names of the arguments, what are their defaults, and what are the acceptable values, or what kinds of things should you put in the, what kinds of things should you use to define the arguments. So, for example, in the paste function, first it's a bit confusing. It shows you this ... and that just means you can put a bunch of different R objects that either are character vectors or can be converted to them, because this pastes together text. And the next most important argument here, the main argument for paste, is you're pasting together text strings. So you want to tell it what character you want to use to separate the different text strings that you're pasting together. So that's sep. And here it shows you sep equals quote space quote. So the default separator for pasted text strings is a space. You'll see an example of that in a second. So let's practice with the paste and rep functions. Okay, let's execute this text.1 character string. We're here in section 5-2, line 5-2.1. And so let's make a new text object here that we're going to call text2. Text.to is, or arrow, and we'll say with some more text. Okay, just execute text.to and make sure text.1 was also created. Now let's just paste these two text strings together. So we're going to use paste, open parentheses, and the first argument is just the first text string, text.1, comma, space. Then we'll put in the second text string, text.2. See, paste is kind of unique because this ... means you can put in as many things as you want, and all of those first arguments are just the things that you want to put together. It's a lot like C, really, the C function for making vectors. So we paste text1 and text2, and we won't specify any other arguments, just execute. Now it makes us one thing. See, it's got the number 1 here, and there's no number 2, because we only got one thing here, all strung together between quotation marks. So this is now a character string with some more text. It just put our two text strings together. Let's try using a different separator. So here in 5-2.2, we'll go paste text.1, comma, space, text.2, comma, space, sep equals quote, and this time let's use an underscore. So if we execute that, now you see we got returned our two text strings strung together with this underscore as the separator. Now let's do one more just to get some practice here, because paste is really, really important. You will need it a lot. We'll paste text.1, text.2, and we will make no separator. So in this case, that's just quote, quote. There's nothing between those two quotation marks. If we execute that, now you can see the string with the junction between those two text strings is just collapsed with no separation. Okay, let's play with rep. Rep is a useful function that repeats things. So let's get some help on rep. So we'll do question mark rep. Rep replicates the values in x. X being the first argument, which is the thing that you give it to replicate. How do we know what x is? Let's go down here to arguments, and where it says x, it says a vector, blah, blah, blah. Basically, just x is a vector. It could be one element, it could be many elements in a vector. So let's give it a try. Here in 5-2.4, let's repeat the letter A 20 times. So let's go rep, quote, A, get out of your quote, comma, 20. By the way, you may have noticed, I'm going to delete this here. You may have noticed that when you open parentheses or quotes, like I just hit quote once and it gave me both of them. That's one of the convenient features of RStudio that makes sure that whenever you open a parentheses, a bracket, or a quote, that you always have the closing one all ready to work with, because it is critical to close quotes and brackets. If you don't, that will cause errors in your code. And you'll have to figure out where that unclosed bracket is and make sure to go find that place and put it in the right place. So it's handy that R gives you that already. Okay, so we'll rep A 20 times. Let's execute. And you see we just get the letter A repeated 20 times. Okay, a little pop quiz. What happens if you don't put the quotes around A? And why did that happen? Rep A 20. Interesting. Nesting functions. 5-2.5. So functions can run, we've just been doing functions on their own like this, but you can also put calls to functions inside of each other. So let's make a new vector, we'll call it v4, and, v4 is c, so we're calling the c function. I'm going to give some space just to make it clear for you here. Now we'll call the rep function. So rep, and we'll open parentheses for rep, because anytime you call a function, you have to immediately open the parentheses so that you can specify its arguments. And we'll rep 10 5 times. And then let's add another element in here, 4. So okay, we've opened up C, which, remember, creates vectors. And now we've got 1 comma that belongs to the C function. Because we know that because, we called rep and we opened the rep parentheses, so now this comma belongs to rep. Then we close the rep parentheses. Notice how when I click next to one parentheses, it highlights the other. That's also really a handy feature of RStudio. So now rep is called and done and closed. Now as we move to the right, that comma belongs again to the C function. And then we put in one more element, which is 4. Okay, let's execute that and see what that looks like. V4. So we get one vector with 5 10s and a 4. Because the first element of our call to C was just a function that produced a vector of 5 10s, and the second element was a 4. So bang, bang. Clearly, as you saw as I walked you through the structure of that nested function, when you start nesting things, it becomes critical that you pay very careful attention to parentheses and commas. In fact, I've been helping people to troubleshoot their code for like nearly 15 years, and it's almost always a comma in the wrong place or missing, or a bracket or parentheses in the wrong place or missing. And usually people think it's something much more advanced than that. Oh, I need to learn how this function works. No, it's just commas and parentheses. Okay, so note the equivalency principle in use above. So if it's okay to write C 10, 10, 10, 10, 10, 4, and rep 10, 5 is equal to 10, 10, 10, 10, 10, then C rep 10, 5, 4 is also acceptable. Do you see the equivalency? If you can write 10, 10, 10, 10, 10, 4, then you can write a bit of code that makes the 10, 10, 10, 10, 10 part, and then the 4. Let's look at an example. Call our iris data again. Take a look at iris. You're familiar with this data set by now. We're going to use the paste function here to fix something that really annoys me in biology data sets, because I'm a biologist and a species is not defined by just that second part of the name. Like, we're Homo sapiens, we are not sapiens. We are Homo sapiens. Homo's the genus, sapiens is the epithet. Our species is Homo sapiens. These species are Iris setosa, and the other irises in this data set, not just setosa. So we're going to fix this annoying problem, and we're going to make the column iris species equal to pasting the text iris with the species column. So we'll execute that. Bang, look at the head. Now all is right in the world. The species has both the genus and the epithet Iris setosa. Notice that we actually pasted a long vector here. So this is a little bit different than C. It didn't paste like the word iris and then one by one adding every other species from that column into one item. It instead pasted iris one by one to every single species in that column. So it was a bit more like when we multiplied a vector of numbers by one number, and it takes that number and it multiplies one by each number in the vector. It's the same thing here with paste. It pastes the one item that we gave it to each of the collection of items. So we have iris. In fact, let me just show you here, iris species. Now we're looking at the entire vector, which has several species, including Virginica and Versicolor, and it pasted iris to each one. Okay, so we've showed you R-help. R-help is going to be the most common thing you want to use to understand how to use a function, because it gives you all these specific details, especially looking here in the arguments area. You can also go down, further down in the help to the nether regions here of details and then examples in the bottom. Often the further you go down in that help file, the less helpful it becomes. These examples are quite logical, easy to interpret. A lot of the examples are way overcomplicated and nothing like the way that you would usually call the function. I don't know why the help files are constructed that way, but that's the way it is. So the most importantly, you need to see the structure of the call to the function, the arguments that it has, and the details for those arguments. If you, for example, don't know what function it is that you want to call, you're like, I don't remember the name of this function. I need a function that puts together two text strings. What was that called? Just Google it. If you Google it, among all of the results that come up, the results from the site Stack Overflow are the most common. But you know what? Now, everything is changing to ChatGPT. ChatGPT has already read Stack Overflow and all of the other sites on the internet, and it knows the answers. The free ChatGPT, though, may make up some weird stuff that just won't work. So be conscious of that. In the paid version of ChatGPT, you can go to find other GPTs. So it's not just chat, but there's a little button to find other GPTs. And there's one called R Wizard. And that is really, really useful. You still do need to learn to speak the R language. You still need my tutorials, because ChatGPT, you can't just tell it, hey, ChatGPT, analyze my data. It's not gonna work. You need to ask it specific things, and then you need to know how to go and apply those and, explore your data, following your own intuition, and that requires you speaking the language. Okay, so we've gone through object vectors, functions. Now we're going to get into matrices, and then what you've all been waiting for, data frames, so that is what is gonna get you help to analyze your data. If you found this video useful so far, by the way, please give it a like, that little like button at the bottom of the video. Subscribe to the channel for more like this and for some cool scientific adventures. I do work in the Brazilian Amazon there. And if you'd like to be the first to know about new tutorial videos dropped on YouTube, or you'd be interested in an online course where I can take you all the way from the most basics of R up to advanced custom functions and iterations, then send me an email at earth.operations.r@gmail.com. Sweet. Let's get into matrices, and then we're going to get to data frames. So, matrices are our first two-dimensional object to work with together here. So we've been learning about vectors. Matrices actually are vectors, but they're vectors that are just wrapped into 2 dimensions. Let's take a look. So first, let's see the help for matrix. So we'll go question mark for the function matrix. So question mark matrix. This function creates a matrix from a given set of values, so from a vector of values. Matrix, you give it the data, your vector of values, and then you tell it how many rows and how many columns you want to wrap that vector into. So you define that second dimension of the vector. Let's see an example here. We're in 6-1.2. Let's make a simple 2-row matrix. So we'll call it mat1, arrow is, I call it is, matrix, and then open parentheses because we're calling a function matrix. And we're going to give it the values 1 through 6. Remember, I'm just going to highlight 1 through 6 here and execute just that. That gives us a vector of values 1 through 6. Okay, so matrix 1 through 6, comma, space, nrow equals 2. nrow equals 2. There we go. We've made mat1. Let's take a look at mat1. I just put that in 6-1.3 there. So now we see something that looks kind of a lot like what is returned when we call a vector, but this time we get all these square brackets with these commas and numbers. And what these are showing us is the indices of each dimension. So on the left of the comma inside the brackets is a 1 here. That's because that's the first row. This is the second row. And then to the right of the comma, it shows us the column indices. So the first column, second column, third column. So a square bracket, rows, commas, columns, and square bracket. Imprint that in your brain. You're going to use it with data frames over and over and over again. And if you get it backwards, it's going to mess you up. Okay. An important note here, matrices are built by columns first, then by rows. Let me just scroll back up here and see. So we made our matrix out of the values 1 through 6. And you see down below, it created this matrix that goes 1, 2, 3, 4. So it wrapped that vector by columns, top to bottom, left to right. That's how matrices are built. Notice also that we only called the argument nrow and not the argument ncol. And that's because the matrix function allows you to call only one of those because it's kind of obvious what the other one is given the length of the data that you give it. If you're going to put it in 2 rows, then it's going to have to make it into 3 columns. So it'll calculate the columns if you only give it the rows. Okay, you can do math on matrices. So let's look at mat1 times 2. And now if we look at the original mat1 here, that was 1 through 6. And now you can see it's turned into 2 through 12. Note again that this is not true matrix math. For matrix math, use the %* operator, as in matrix 1, %* matrix 2. If you're into that kind of math, I'm not personally. Okay, I'm scrolling down here. We're approaching 6-1.4, and we're going to get into indexing in matrices. So again, indexing means pointing at things in your structured data sets. For 2-dimensional indexing, we use this format: square brackets, rows, comma, columns, and square brackets. Rows, columns. Rows first, then columns. Rows, columns. Remember that. Rows, then columns. You get them mixed up, it's going to mess you up. And you might not even know that you messed it up until your data comes out really weird somewhere downstream. Okay, For example, let's look at the second entry, at the entry in the second row of the third column. So if we're calling rows columns of mat1, you probably already know how to do this. So mat1 is square bracket, second row, third column. Oops, I didn't mean to do that. Yeah, R helpfully gave me an error there. It's like, what are you doing? That didn't make any sense. I didn't mean to redefine mat1. I just wanted to call the second row and the third column. So there we go. If you leave one of those indices blank, so that means one of these positions left or right of the comma, then it will return everything. So we're here in 6-1.5, and we will go mat1, just blank space. I'll just give it a little space to make it clear, comma 2. Hit enter, and let's just look at mat1 so you can see what it showed us. So when I called mat1, comma 2, it returned 3, 4. It returned just a vector of values 3 and 4. That's because I called that column, and there's the 3 and 4. Okay? Right. In this line, I wanted to try, let's just try multiplying everything in that second column by 2. So all it is you do that indexing where you access that second column, and you just go times 2. So it takes everything in the second column, multiplies it by 2. Let's try redefining some of the entries in mat1. So we want to get in there with like a scalpel and adjust some of the values. So here we go. We're going to say mat1 square brackets space comma 2. So we're going to change the values in the second column of mat1 by saying equals. Here's where I use equals instead of the arrow, because I'm just going to modify values rather than creating a new object. So second column of mat equals mat1 square brackets comma 2 times 2. Okay, execute that. Let's look at mat1. Now mat1 is its familiar 1, 2, and before it went 3, 3, 4, 5, 6. But now we took, up here we said, okay, return to me the second column, the values in the second column of mat2, and let's make them now equal to the second column of mat2 times 2. So it may seem counterintuitive to you, why are we repeating this again here? It's because once you get to the right side of the equals sign, R has no idea what you're going to want to multiply by 2. Here we just pointed to where we want the result to go to. So we said we want to make the second column of mat1 equal to something. So we have to put here specifically that, oops, I'm going to copy that and paste it and put it back in here, that we want the second column of mat2 times 2. If you execute just that half, you see it's those two. Well, now it's those two values because we already turned it to 6 and 8. And then when you execute the whole thing, there we go. We have again transformed the second column multiplied by 2. Don't worry too much if some of this seems confusing. It's as you gain practice with it, it's just going to install itself in your brain a lot better than if you just tried to like memorize the rules behind these things. So that's why you do these type after me tutorials. Okay, 6-1.7. So we'll use vectors for multiple indices like we have seen before. So let's look at mat1 and open our square brackets so we can index within it, space, comma, and we're going to go 2 through 3. So this means that since we're on the right side of the comma, then we are accessing the columns of mat1. The left side of the comma is blank, so that means give us all the rows in columns 2 and 3. Execute that, and we get this smaller matrix with these second 2 columns. You might notice that this now gives us the numbers 1 and 2 instead of 2 and 3, which is where we took it from. That's because we basically just created a new matrix here temporarily, and these are the first 2 columns of that matrix. You can also index matrices one-dimensionally, because remember that matrices are just vectors that are wrapped into 2 dimensions by columns. So if matrices are vectors, then you can index them just like vectors. So for example, let's ask R to show us elements 3 through 6 of mat1. So we'll go mat1, square brackets 3 through 6. I'm not putting any comma in here because I'm indexing just like I would in a vector, which has 1 dimension. There's no rows and columns of a vector. There's just 1 dimension, so no commas. Okay, and now you can see it shows us the 3rd through 6th values of mat1. Here, let's just look at mat1 so you can see. So it counted by columns first, 1, 2, 3. It started here, and then 4, 5, and 6. When do you really use matrices? I don't actually use them that often. They do come up when I do these particular fast iteration functions, but they're a bit too complicated to show you an example of now. But people do use them when they have any large 2-dimensional arrays of values of the same class, like images. Images are rectangular collections of values, 1 for each pixel. And R can actually do math and analyses on those matrix objects actually a lot faster than it can on data frames, which are the spreadsheet-like objects that we're about to learn next. Okay, we've gone through objects, vectors, functions, matrices, and finally we are on to the part you've all been waiting for, data frames. We're going to learn what they look like, how to use them, and then how to call your own spreadsheets into R so you can start analyzing your own data. I'm going to end this video here, but if you want to continue on with the tutorial, just find the next video in the series. There's a link to the whole playlist of my R tutorials in the notes below this video. If you found these tutorials useful, please give the video a thumbs up, consider subscribing, and let me know in the comments below what you found most useful from this tutorial and what you found most confusing. That'll help me to make better tutorials in the future, and it'll help other people to find these and benefit from them like you have. And if you'd like to be the first to know when my next tutorials drop on YouTube or when I have an online course offering and you'd like a link to be able to sign up, send me an email at earth.operations.r@gmail.com, and I will let you know when anything new in the R tutorials world happens. Thank you so much for joining me. I'm Ty Taylor from the Operator's Manual for the Planet, and I will see you in the next tutorial. Peace.